Hi, everybody. Welcome to part 4 of today's educational content. We are talking how to build RAG with LangChain and open source models now. We're going to use Gradient as a place to host the open source models we're going to use and to fine tune the open source model that we're going to use, which is, of course, Llama 2 today. So, just sort of making sure that we're completely aligned today. You're going to understand the key aspects of Gradient. You're going to understand how to host the models, how to fine tune the models, and how to use those models to build RAG systems. So we'll go into those open source models, what this kind of looks like, what the use cases we're doing today, and then we're going to go into fine tuning and RAG. So go ahead and first consider when we use ChatGPT, we're essentially asking a question, something like, do I need to learn gradient descent to build LLM applications? And we get some answer. This is a often disagreed upon answer. Do I need to learn gradient descent? Do I not? For instance, Andrew and deep learning put out the sort of essential algorithms one needs to know. And honestly, as time progresses, I feel like you should probably know gradient descent if you want to get deep into LLM world. In the end, you kind of can't avoid it, especially as you get more and more into training and fine-tuning models that are getting more and more complicated all the time. So we were interested to build a system that could answer the question, what does research tell us? If we look at the papers on gradient descent, can we get more of a definitive answer on whether or not we need to learn this? And so instead of tapping into the OpenAI API with a simple input and receiving a simple response, like building your first LLM status, we want to instead try to do this open source. And we've got some resources associated with doing this open source, but this is even easier to do open source when you're doing it with a tool that hosts the models like Gradient. And so when you're building open source, a lot of times you need to load the model and the tokenizer. You need to configure any libraries you're going to use for quantization and doing things that are going to streamline the efficiency. And you got to define stopping criteria for when you're done training, or for when you're sort of want to make the chat model less verbose. And of course, you need to build the pipeline. If you're going to use Hugging Face tools, the Hugging Face pipeline tool is something that probably many of you are very familiar with today. And so while OpenAI is doing amazing things, we saw it recently in OpenAI's Dev Day, things are getting easier for devs on the open source side too. It's not just those models we talked about in the first session, all those new ones that have come out, Anthropic, Inflection, Perplexity. It's also that there are platforms being built to help us with open source. So they can allow us to move through these steps of building LLM applications like prompt engineering, question answering, or RAG, and into fine tuning even more easily. And we can fine tune those open models just as easily as we can fine tune OpenAI now. So when we do this with a tool like Gradient, we're not doing anything fundamentally different, but we are streamlining the way we engage with these models. So we don't have all this extra stuff that we need to worry about downloading everything ourselves, hosting it, really connecting everything up. A lot of that heavy lift work is done for us already. So shout out to Gradient. If you go ahead and sign up for Gradient, you'll get $5 in free credits. That should be enough for you to host your own chat model and even potentially instruct-tune that chat model and leverage that for your hackathon project today. So what we're going to do is we're going to host a chat model, instruct-tune it. We're going to host an embeddings model, and then we're going to build a RAG system with these two models. So first off, let's take this instruct tuning piece and let's talk about instruct tuning for just 1 second. This is the idea of supervised fine tuning for alignment with humans to make it more helpful, right? We want it to be helpful given the instructions that we provide the large language model. And this is the idea of it sort of understanding our input and really engaging with us in a way we would expect. Now, when you go and you try to set up instruction tuning, what you're going to do is you're going to train with prompt response pairs. And you're essentially just going to show it a lot of examples of the way we want to be engaging with the LLM given a particular instruction. And you'll notice here there's some boilerplate within each of these pieces of data we use for fine-tuning with the Instruct v3 dataset from Mosaic ML. Below is an instruction that describes a task. Write a response that appropriately completes the request. Instruction, I'm getting into music history and want to listen to some authentic analog music from the 1980s. Which of the following modalities should I try? Et cetera, et cetera, et cetera. Here's the kind of response that we would want to get. And these are responses that we make sure are aligned with humans. We're sort of showing many examples in different domains during this instruct tuning process. So let's see exactly how to get gradient set up, host Llama 2, and Instruct-tune Llama 2 with Wiz and his very next demo. Over to you, man.
All right, everybody. So, open source with Gradient. First of all, and probably the most important, we will need to sign up for Gradient. So the way you can do this is provided the notebook, and I will share the notebook link right now so that everyone should have access to it. Here you go. And it's simple enough. You get $5 in free credits. And once you're done, you get this kind of, thing. You can see here that we have access to a number of free tokens. So if you see here, we have these $5 of credits that we can use through Gradient. Very cool, very cool. Once you have signed up, you'll get to this page. You want to create a new workspace, give it a name. And that workspace is going to be how you can see what you have done on Gradient. You can see that you can fine-tune and test your models through the UI. You can see the fine-tuning that you've done. You can see the testing that you can do right through their chat interface here and get your API token. And so this is the tool Gradient. Essentially what it is it's a LoRa adapter that sits on top of a hosted model, and you only pay per token used with Gradient. So it's very similar to OpenAI's system, but it is, you have access to the adapter, you can fine tune it and everything like that. That's it. Now, what we're going to do today is we're going to fine tune the Llama 2 7B model on a instruct data set. What are fundamental differences between instruct and chat model? An instruction tune model is fine-tuned for the task. This is going to sound very silly now that I'm saying it, but an instruction tune model is fine-tuned for the task of following instructions versus a chat model, which is fine-tuned for the task of chatting. Now, obviously, what's the difference between chat and instructions is the question that I'll answer, so that the answer is not just a non-answer, but the idea of a chat is keeping track of what's been said and then responding in turn, right? But you don't actually have to know how to extract concepts from text or provide an answer in French, right? Like, the idea of chatting is that you have this idea of back and forth, but that's just one task, right? The chatting task. An instruct-tune model is going to be good at a wide range of tasks. So things like sentiment analysis, or the ability to open-ended answer questions, closed book answer questions, the ability to translate, the ability to extract key concepts, the ability to summarize. All of those things are instructions in that instruction space versus just that one task, which is chatting. And what we're going to focus on today is the Mosaic Instruct v3 task. You can see this is just a set of instructions and responses. And so we're going to fine-tune Llama 2 7B chat through Gradient in order to be a better instruction follower. Is creating query or training the data done on an instruct model, and QA is applied to chat model? QA can be instruct model or chat model, preferably instruct model, depending on your system. If you're doing like a closed RAG system, then you actually want it to be instruct tuned, versus chat. Chat model is generally the one your user is going to interface with. And we do want to pick up off the shelf, if we can, an instruct tune model to fine tune, because they're already good at a wide range of tasks. So like we would normally do, we're going to grab some dependencies. We're going to use Llama Index because they built a helpful wrapper for this in order to train Gradient. You'll notice that we have to provide our workspace ID and our access token, both of which can be found through the Gradient dashboard. We're also going to use Hugging Face's datasets library to manage our dataset. First thing that we're going to do is we're going to convert our dataset to a JSON-L format in the appropriate format. So the idea here is that Llama Index expects there to be a JSON-L format, so we need to have it in that format. That's it. Now, one of the things to keep in mind is that Gradient uses what's called batch fine-tuning. So it's going to iteratively train your adapter every time you send it new examples for X steps, where X is the number of examples you sent. So this is actually can be an asynchronous process. You could just send, periodic samples at a time. So it can be used for keeping your model up to date or changing its behavior relatively frequently. First thing we're going to do is load the dataset using the load dataset helper function from the datasets library. We're going to take a peek and see that there are 56,000 rows in train, and there is 68,000 or 6,800 rows in test. We want to convert all of our prompts into the following format. You'll notice that we include the beginning of sequence and end of sequence tokens. This is just to make sure that we learn the correct prompt strategy. And then we are going to, and again, you might say, well, hang on, Chris, but Llama wants the INST token set and end of text beginning. That's true, but the performance was found to be subpar in fine-tuning by the Llama Index team, and it was found to be better using traditional beginning of sequence, end of sequence tokens. So all we need to do is take our data set, which we saw here, and we need to convert it into this format. So we're going to do that. We just use string parsing to do that, and then we map this string parsing to the entirety of our data set, and we create a new row called inputs. This is the key that, or the column, sorry, that Llama Index expects, and so that's why we choose it. Once we've mapped that, we can look at an example, and you can see that we indeed have applied our template to this example. That's great. We're now going to, due to a limitation or restriction from Gradient, we're going to just use short examples. Now, they have a cap of 2048 tokens. We're going to choose character length of 2000. We're only going to train this for a few steps, so we don't need to use a tremendous number of training examples in the first place. You could be more specific about this by using Llama 2's tokenizer to tokenize your inputs and then cut them off if they exceed this range. But we're just going to use this naive filtering strategy because we only care to train a few examples anyway. You'll notice that cuts our training set down by quite a bit. Same with our test data set. But now that we have done that, we can go ahead and save this as a JSON-L file. And once we have our data set formatted in a JSON-L, we're good to start fine-tuning. We're going to initialize our base model using the Llama 2 7B chat base model slug. The slug is the ID for the Gradient service. And we'll see that the max tokens for this base model is going to be 300. So it's going to be capped at 300 tokens of generation. It's always good to set a maximum on your generation tokens to avoid a situation where you have like 4,000 tokens generated or whatever the maximum is for that model, and you wind up paying a little bit extra. So we're just going to keep it at 300. Now we can initialize our fine-tune engine. The fine-tune engine is going to take our base model slug. We're going to give it a name, which we can refer to it from later. We're going to show it the data file that we want to train it with. We're going to set this verbose equals true flag just so we can see the outputs. We're only going to do a maximum of 100 steps, and we're going to do batch sizes of 4. Now, the way this looks behind the scenes is we're going to use Gradient's batch fine-tuning endpoint to send 4 examples at a time to the fine-tuning endpoint, which it will train, and then we're going to do that for 100 steps. Great question from Eva in the chat. Why only 100 steps? Because it was a reasonable balance between cost and performance. We don't want to use too many tokens, and it's just for a demo purpose. You could do easily 10,000 if you wanted to, but you're going to be paying per token. And so 100 steps is a nice, comfortable place to get a feel for what the tool can do without blowing up your bank. And should be covered under the base $5 credits that you get from Gradient. We're going to show the model 400 examples by doing 100 steps of 4 batch size. And so that's what we're going to train our model on. Is there a reason you use Llama Index? Yes, because it's convenient and they built this fine-tune engine for Gradient. That's it. Now, we're going to go ahead and grab our fine-tune engine's model adapter, and we can just start fine-tuning. You'll notice we just do this in a loop, straight up in a loop. That's it. Llama Index made this very easy, so we do 1 epoch, and then we fine-tune for that epoch. You'll notice that we have our number of steps, which increment by 4. Since we're sending 4 batch sizes or 4 examples at our batch size at a time, we have our loss. Our loss goes down, but not consistently. Totally fine. Fine-tuning these systems, you'll soon learn that the loss is not necessarily the greatest indicator of what's going on. The big idea here is we just want to show it a lot of examples of the behavior we desire. More steps takes more time, not necessarily credits. That could be true, but I believe Gradient is charging per token for training. So I'll double check and get back to you guys if that's different. What is the difference between doing fine-tuning on Gradient compared to OpenAI's fine-tuning feature? So OpenAI's fine-tuning feature can only be used for OpenAI models, which is the limitation. Gradient can be used with a number of open source models. So that's the main difference. Now that we've fine-tuned our model, we want to be able to access our model. So we're going to access it through our LangChain. We can also access Gradient's embeddings model. Now, right now, they only have BGE large, but they're working on adding new embeddings models all the time. This is going to work exactly the way you'd expect it to through OpenAI. We pass it a phrase, and then it returns a vector of length corresponding to your model. In this case, BGE large returns vectors of size 1000. So that's great. We can access the embeddings model just like we would OpenAI, but it's through Gradient, and it's using the BGE large embeddings model, which you can find on the embeddings leaderboard. Now, how do we access our model? Well, basically, all we need to do is, again, through LangChain and the Gradient LLaMA object, just like we did through OpenAI in the first notebook, we just pass in the adapter model that we want, and then we can set these quargs. In this case, we're using 128 maximum generated tokens, and we're using the last model ID since that's the one that we trained. If we were to look at the models here, you can see our base model adapter, and this is its ID, versus our Instruct-tuned model and its ID. And you can see that these are sorted in terms of when they were created. So the ones that were created last are the ones that we're going to use. So you could grab it right from the UI if you wanted to, or you could use the API to get it just in your notebook or whatever terminal you're using. Now that we have our Gradient LLM set up and our embeddings model set up, we're basically ready to go. The only thing we have to do is we have to add our prompt for RAG. We're going to add that prompt that is going to describe the task, and then we're going to ask it to continue on in a way that makes sense. We are going to create an LLM chain using the old school format of LLM chain. We could use the pipe notation, but it's good to see both. And then we can run this query. What is the opposite of gradient descent? We get the opposite of gradient descent is called stochastic gradient descent. Now, that's not necessarily what we wanted to see, right? So let's see if we can make this, or see if it's a little bit better. What we're going to do is we're going to add some context, and then we're going to do the same thing again. This time we're going to use our LCL notation instead of the traditional LangChain notation. And we can ask questions like, what is the opposite of gradient descent? And then pass in some context related to gradient descent and see that we get the response of steepest ascent. So now that we've passed this additional context, our LLM's response is much better. You know, the opposite of gradient descent, certainly it'd be hard to argue that it's stochastic gradient descent, whereas steepest ascent seems close enough. And then you can create ask a question that it should not know the answer to, in which case it responds with, I don't know. Again, we ask it the question about the unladen swallow, and then we give it a gradient descent Wikipedia article as context. It has no idea. There you go. Now, we can extend this example using the archive loader tool from LangChain, which is going to query archive for papers about gradient descent, and then load them as documents, which we can then split into chunks. And that's it. And with that, we'll head back to Greg.
Yeah, Chris, so awesome. We're just going to make sure that you're situated properly within this context of RAG and what we're actually trying to do here. There's a lot of moving pieces compared to the simple things we started with today. Recall RAG, we provide a query, we turn that query into a number, we look for similar stuff, we get our prompt template set up, we shove that similar stuff inside, that goes into the chat model, and we get our answer. The two models that we're focused on here, the embedding model and the chat model, these are the things that we're paying some attention to today with Gradient. These are now, instead of being OpenAI, they're hosted on Gradient's platform. And the way that we connect all of this stuff together is we're connecting it using both LangChain.
Hey, Greg, we're not able to see your slides.
Ah. The way that we're connecting all of this together, as we talked about, is we're using LangChain as the glue to sort of piece it together exactly the way we saw before. We're using Llama Index as a fine-tuning wrapper for the chat model, as Chris just showed. And we're using Face as a vector store. We're also going to leverage the built-in tooling within within LangChain to connect to archive. So we've got LangChain, Llama Index, Face, the Facebook AI similarity search, and archive. So you might visualize this something like this, where we're really connected through LangChain to archive. We've got our Face vector store. And again, the glue here is holding all of this together. Llama Index was simply used to help us to instruct-tune the chat model. And so as we saw, we are going to leverage the BGE base model, the one that's available to us on Gradient, the Llama 2 7B chat model. And so we end up having something that looks like this at the end of the day to try to kind of keep track of all the different pieces and parts that are moving. Finally, we're going to allow this sort of meta gradient flow that we're going to search the top 5 papers on archives for gradient descent. We're going to go ahead and get those things into our RAG system by turning them into vectors that we can search for similar things within. We're going to be able to return sources. And of course, as Chris mentioned, Here, he showed both the LangChain classical and the LangChain expression language. This easier way that they've developed to compose chains is the one you want to default to as you start working with LangChain now and into the future, because it's going to work a lot better with some of the new tooling like LangServe and LangSmith that they're putting out. So let's go ahead and see the rest of the RAG build from Chris and see, do we really need to know gradient descent these days? I wonder what the properly built RAG system will tell us. Wiz, over to you.
All righty. So yes, we are going to go ahead and we are going to do the thing. So we're going to create a RAG chain and LangChain using gradient-backed services. First thing we're going to do is get some dependencies. We'll grab face CPU, archive, and the PDF parser. This is so that we can parse the PDFs obtained from archive and then chunk them appropriately. Again, we're going to load 5 papers from archive with the query gradient descent. We're going to split those each of those papers into chunks based on this chunk size of 1250, again, using the recursive character text splitter. We're using that because we know that we have papers and papers have sections and sections have paragraphs. So again, it should be a reasonable way to split information. We'll go ahead and split those. We'll split our 5 papers into 227 chunks. And then we're going to go ahead and embed each of those chunks. Now you'll notice here that we have this these 3 lines. This is because Gradient's API is currently limited to 100 embedding examples at a time. So in order to embed all of our documents, we'll have to split them into 3 chunks. You can write code that would automatically batch this for you. But for right now, we're just going to do it manually so you can see and be transparent that they're only taking 100 samples at a time for embedding. We'll then set our retriever up from our vector store using the .asRetriever method that we saw previously. This is to let us use the retriever API for our vector store. Our vector store is just face. So this is a relatively open source example. We'll then set up our chain. Hopefully this looks a little bit familiar, as it's exactly what we saw in the first notebook. We have our context, our question, which is passed and then formats our RAG prompt, which is chained into our LLM, which is chained into our output parser. We then have the ability to invoke our chain with the query, what is gradient descent? Gradient descent is a method of minimizing a function by iteratively adjusting parameters in a function to reduce the value of the function. Cool. Is it mandatory to learn gradient descent in detail to build large language model applications? No, it is not mandatory. What do I need to learn about gradient descent to build large language model applications? You need to learn about gradient descent's applications and its limitations. And so the idea is that we can build a RAG system using totally open source Instruct-tuned models that we did the work on ourselves, and open source embeddings, all powered by Gradient, which we're paying per token for. So while this is idling or not in use, we're not paying anything, which is huge. And that's it. That's how we can leverage Gradient to power our applications. So if you were thinking you wanted to use an open source model, but you were unsure about where to host it, Gradient is an excellent solution, and their free $5 credit should be enough to get you through the day with no issue.
Awesome. So what we saw in conclusion is we saw that open source models can actually be pretty easy to use if you pick ones that are hosted on platforms like Gradient. And you've got the model accessible and you've got the fine-tuning accessible through the platform, which is really cool. The RAG systems and putting these together with the open source models in truly sort of an open AI kind of way is getting easier and easier all the time. Now, if you want to learn how to leverage open source models, not from a Gradient platform, but rather what you need to do exactly to get set up, check out session 5, 2 sessions from now, and we'll be diving into that. And if you want to learn how to fine-tune embeddings, we will show how to do that sort of in a similarly open source way in session 8.